Well, this is to you all. Dear students, in this video, we are going to learn about the Gauss law of Ba. The scientist associated with the design of electronic configuration of an element means how the electrons are going to fill in the respective subcells. Respective subcells, what I mean talking about that one? It means according to the Afbah rule, he started that outside the nucleus, electrons are going to fill accordingly from the minimum energy level subcells proceeding to the higher level. Means electrons are first getting filled into the subcell which is having less energy, and then gradually it is increasing to the higher energy level. Then how we can say which subcell is having less energy, which subcell is having more energy? Then this is designed by N plus L rule. You can see N plus L rule is there. Just like when I am just writing like that, N L to the power x, this is just like 1s2, 2p6, 3d10, it is just like that. It means this is indicating N and this is indicating L. For your convenience, dear student, I am just going to write L value is 0, 1, 2 and 3 representing S subcell, P subcell, D subcell and F subcells respectively. If the value of L is 0, it means it is S subcell. If the value of 1, if the value of L is equals to 1, it is representing P subcell. 2 means D subcell and 3 means F subcell. So if you are getting a sum of N plus L and the electrons are going to fill from the lower value of N plus L. Suppose that I am just giving an example here. Look at this. We are having the two subcells 4s and 3d. You are able to see here. This is the fourth cell and this is the third cell. Then basically one can think the electron will fill in the third cell first and then will move into the higher energy, that is the fourth cell. But it is not so. Electrons are going to fill firstly in fourth cell and then the 3d is 4s is filled before 3d. What is the reason behind that? You can have the answer with the help of N plus L. Here the value of N, here is N plus L. The value of N is 4 and the value of L is equals to 0. You can see here the value of N is equals to 3 and the value of L is equals to D is there, that's why it will be 2. The answer is very clear, it is 4 and it is 5. Then definitely this is the lesser value, and due to the lesser value of N plus L, it will be filled first. So if anybody is questioning you, why 4s is going to fill before 3d, then you can make the answer with the help of quantum number N, L. With the help of N plus L rule, those subcells are getting filled first which are having lesser or lower value of N plus L. Keeping this rule in our mind, we are just going to learn how the electronic configuration of different elements are going to be written. Here it is. You have to make a small chart like that, what I am doing here. You can see I am just writing the cell with respective subcells. These are the respective subcells. Fourth is having 4, fifth is having 5, but we are just writing only 4. 6 is having 6, of course, but no need to write that. We are writing only 3, and 7. We are just having only 2 subcells. That is enough for us. These subcells are getting matched obliquely with the arrow marks, and now you are having the proper way to have electrons filling in an empty subset, that which is having of course the lower energy. First 1s is filled first, followed by 2s, and then 2p, 3s, 3p. Look at this. After 3p, 3d is not going to fill, but after 3p, it is the 4s orbital which is going to fill first, and turning back, it is again 3d. Similarly, after 3d, it is 4p, and 4p is not followed by 4d, but 4p is followed by 5s, and after 5s, it is 4d. Then these are having a simple representation of the electronic configurations. You can write it well. Here it is the way to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. With the help of this one, you can write the consequences like that. For example, if I am writing the electronic configuration of chlorine. So chlorine is having 17 electrons, and we have to write the electronic configuration of the chlorine starting from 1s2, 2s2, 2p6, 3s2 and 3p. Wait, I am just counting the total number of electrons what I have filled. 2 and 2, 4 and 6, 10 and 2, 12. I am having only 5 electrons and we can have maximum 6. Thus, I am able to write 5 electrons here. This is again a simple representation of the electronic configuration. One more thing I am just going to teach in this special video, that is about the exceptions. What about the exceptions? Some exceptions are there. If you are having the configuration ns2 and n minus 1 d4, then this is nearly very stable. It is very close to be stable. That's why it is just changing into the stable configuration by placing one electron from ns to the n minus 1 d4. It turns into ns1 and n minus 1 d5. This is half filled stable orbital. Half filled stable configuration, you can write stable configuration, and due to the stability it is preferred well. For example, I can have an example there. Chromium having 24 electrons. The configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d4. 24 electrons are there. You can count them here. Once again, you are able to see this configuration. This is very similar to that 4s2 and 3d4. Then one electron is shifting from here and moving up to the 3d. The configuration changes and now it becomes 1s2, 2s2, 2p6, 3s2, 3p6. Here it is 4s1 and 3d5. It is rather more stable due to the half-filled stable configuration. One more exception is there. If there is ns2 and n minus 1 d9 configuration, it is nearly very close to the stable configuration, that is ns1 means one electron is shifting, ns1 and n minus 1 d10. The example here again we are having an example, that is copper 29. I am writing the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d9. You can shift one electron from 4s to the 3d because this is very close to the stable configuration. If d10 is there, it is complete filled, means full filled stable configuration. That's why the configuration gets changed and it is now 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. It is stable one. Why it is stable? Because it is full-filled stable configuration. This is about how we can write the electronic configuration of an element. Starting from the very simple one, with the first one, hydrogen, and putting one electron successively into the one proton successively into the the electron into the much more higher energy level. Then thank you.